I met several of you this morning, but good morning for those whom I haven't had the chance to talk to. My name is Roberto Lopez. I'm professor here at the University of Maine in the Department of Civil and Environmental Engineering. I lead the thrust area on materials in the Transportation Infrastructure Durability Center. And I'm going to moderate this session. This is a very special session where we're going to look at composites advances and future direction from the industry perspective. And for that reason, we have two experts from industry. Our first presentation is titled A Decade of Innovation. And this is going to be given by Dr. Joe Fox. And he's going to talk in particular about the impact of the Institute for Advanced Composites Manufacturing's Innovation, IACMI. Joe is a consultant for the specialty chemicals and materials industry. He's the president of FX Consulting in Dublin, Ohio. Joe is a chemist by training and has a bachelor's degree in chemistry from Lehigh University and a PhD in chemistry from Penn State. He has 40 years of experience in the chemical industry. He has worked in many important companies like Standard Oil of Ohio, BP America, Ashland Chemical, and Ineos Composites. He's a very active member of IACMI, I mentioned before, as well as the American Composites Manufacturers Association and the American Society of Civil Engineers. So we welcome Joe.
Thank you very much, Roberto. And the first thing I need to do is apologize to everyone for not being there in person. Yesterday was a travel day that you want to forget. I was coming from a bridge conference at NC State. I made it to LaGuardia, missed my connection to Bangor by about 30 minutes because we had circled the airport because of air traffic for nearly an hour. When I landed, American Airlines had rebooked me, but told me I would not get to Bangor until this afternoon. So we had to go to Plan B, and this is Plan B. And it's a pleasure to be able to talk to you virtually about a decade of innovation and IACMI's impact. My outline is very simple. IACMI is celebrating its 10-year anniversary this year, so I'm going to give you an overview of IACMI and talk about its impact in its first decade of existence. The majority of my presentation is going to be the second item, and that I want to give you an overview of the activity within IACMI's Infrastructure and Construction Working Group. So a little bit of IACMI 101. IACMI stands for the Institute for Advanced Composites Manufacturing Innovation. It is also known as the Composites Institute. It is one of 18 Manufacturing USA institutes that have been created to revitalize advanced manufacturing. It is a public-private partnership that involves industry, academia, and government. It was created by the Department of Energy in 2015 and renewed in 2023. And over its lifetime, IACMI has evolved and expanded in scope. It had 122 members when it was founded in 2015. It now has more than 170 members. So IACMI is really an ecosystem of collaboration. I mentioned that it is a public-private partnership. It involves industry. You've got OEMs, you've got small to medium enterprises or SMEs, and you have startups. It also involves academia, universities doing R&D, and community colleges and trade schools mostly involved with workforce development. And there's government involvement. You have federal laboratories involved, and you have funding from numerous federal agencies and state economic development agencies. And I really like this quote from Steve Bassetti at Michelman: IACMI has a collaborative culture that increases the speed of innovation. So IACMI is also an ecosystem of innovation. As I said, it has more than 170 members. They are all listed here in alphabetical order. There are industrial members, fiber suppliers like Zoltech, resin suppliers like Arkema, equipment suppliers like MVP, software providers like Dassault, fabricators like Strongwell, and OEMs like Airbus and Volkswagen. It also involves academia, 13 universities, including the University of Maine and the University of Massachusetts Lowell, and more than 30 Community colleges and trade schools, again, involved mostly with workforce development. There are 2 national laboratories part of IACMI, Oak Ridge and NREL. And you have very important end users involved, state DOTs and the Army Corps of Engineers, all comprising an ecosystem of innovation. So Chad Duty, the CEO of IACMI, likes to describe IACMI this way. You've got this ecosystem, and then you have 2 key pillars, workforce development and technical innovation. And when you add all that up together, you get better products, better processes, and better people. I'm going to focus mostly on the technical innovation pillar today because IACMI provides technology for nation-critical industries like transportation, energy, aerospace, and infrastructure. And there are also cross-cutting technologies like simulation and modeling, recycling of composites, and advanced materials and processes. Those 2 key pillars, technical innovation and workforce development, form part of a very important equation because when you add them together, it really equates to economic growth. On the technical innovation side, IACMI has completed more than 70 projects and more than 24 innovative new products have been commercialized. Some of them are shown here. On the workforce development side, IACMI has trained more than 18,000 people of all ages, they say from K to gray, through customized education and engagement programs like ACE, ACCP, and Integrate. So in celebration of its 10-year anniversary, IACMI has put together what it calls its Project Impact Report. I was part of the team that put this together, and it really is a 36-page document that is full of impactful stories and stats from the first 10 years. I was going to bring you hard copies if anyone was interested in this report, but if you are, I'll provide my contact information at the end and I can provide you electronic copies. It's worth a read. So now I want to move into the second part of my presentation and focus on IACMI's Infrastructure and Construction Working Group. So IACMI's tagline is convene, connect, and catalyze, and they use various mechanisms to accomplish their mission. I'm not going to talk about all of them. I'll just highlight networking, interns, world-class facilities, world-class expertise, techno-economic analysis. I'm going to focus on the working groups. IACMI has 5 working groups, and they're all shown here. They typically have quarterly meetings, and they can be both virtual and in person. I and John Unser, who is in the audience from the Composite Applications Group, are co-facilitators of the Infrastructure and Construction Working Group, which was created in 2020. So what is our motivation for having an Infrastructure and Construction Working Group? Well, it's very clear that infrastructure continues to be a hot topic in our nation. In 2021, the infrastructure bill provided $1.2 trillion of funding to improve our nation's infrastructure, the biggest investment of its kind in our nation's history. That has spurred a lot of projects. There are still a lot of projects underway that are funded by the IIJA, and when they are completed, you'll see in a few minutes that there's still a lot of work to be done. The second motivation is that there is an extremely good fit between FRP composites and our nation's infrastructure needs. And I say that because of the attributes listed here. Composites are lightweight and easy to install. They're extremely corrosion resistant. They're extremely durable and long lasting, and they are resilient to extreme weather events. I'm sure that many of you are familiar with the ASCE Infrastructure Report Card. It is issued every 4 years by the ASCE, and the most recent one was issued on March the 25th. There are really 2 documents, a full report and an executive summary, and they are both very well worth a read. So here are the grades in the report card, and if you take a quick look at them, I think you'd agree with me that this is not the kind of report card that you want your kids to come home with. There are 2 B grades, 7 C grades, and 9 D grades, and the overall grade is a C. So it's very, very clear that there is a lot of room for improvement. Here's another important table from the report card. It gives the needs and the funding. And you look at the bottom line here, and you see that there are trillions of dollars in needs and in funding. The ASCE will say that the IIJA was just a down payment and that there is a tremendous amount of need still that has to be fulfilled. This represents a tremendous opportunity for composites. Now, they are not going to be able to get all of this $9 trillion, but even if they got a small slice, 0.1% of 9 trillion is $9 billion, and that's $9 billion of opportunity for composites. So I'll come back to this slide and show you this Venn diagram. I've talked about the need from the report card. I've talked about the opportunity and trillions of dollars of opportunity, and I've talked about the fit when I showed you these attributes. So I hope you'll agree that infrastructure represents a very significant opportunity for composites, and that's why we have an IACMI Infrastructure and Construction Working Group. So let's just talk a little bit about the working group. Here are some of the notable members. You've got fiber suppliers like Owens Corning and Torrey. You have resin suppliers like ExxonMobil and Trimer Technologies. You have composite fabricators like Strongwell and Orenco, which was recently acquired by Advanced Drainage Systems. You have the Florida DOT and the Maine DOT. You have the University of Maine, and you have ACMA. That's a pretty good list. So, since its inception, the working group has pursued a parallel path strategy for R&D projects. The first thing we do is constantly develop a list of potential I&C projects. They could be either research projects or demonstration projects. And at the same time, in parallel, not in series, we are trying to identify and secure funding for I&C projects, pursuing funding from the DOE, the DOT, the EPA, NEX, and other funding sources. So John Unser and I are constantly monitoring things like grants.gov and the DOT Navigator for opportunities. And the reason we have a parallel path strategy, the rationale is that we want to have projects that are already well-defined once funding becomes available. So I'm going to tell you about some projects and activities. I'm going to tell you about the past, present, and the future. Let's do past and present together. I'm going to talk very briefly about the 5 projects on this slide. I'm not going to read them to you because you're going to see this slide repeatedly. 4 of them have been completed. 1 is still ongoing. So let's start with the Morgan County Bridge. In 2021, IACMI was part of a project team that demonstrated that you could install this bridge in rural Tennessee. It was part of a team that also included Composite Applications Group. John Unser is in the audience, was a very important part in coordinating the project team. The project team worked very closely with the local authorities in Tennessee, and they used some composite technology from structural composites to install this bridge in just 1 day. Lightweight, easy to install, extremely durable. And I think this project is also a very good example of cooperation and collaboration within IACMI. It actually won Sampy's Del Monte Award for Innovation Excellence in 2022, and all of the organizations that I've highlighted there were members of IACMI. When the bridge was installed, it was instrumented to monitor its durability. That work was done by Luna Innovations and the University of Tennessee, Knoxville. And I'm very pleased to report, and John would be very pleased to report, that after 3 years, there have been absolutely no issues with the bridge. And it's also fair to say that IACMI and CAG would like to extend this technology to short span rural bridges in other states. So it's good that John there in person. Let's move to the second project, the ASCE webinar on design. This webinar really addressed a barrier to the adoption of composites, in that many structural engineers are very comfortable designing with steel and concrete, but they're not nearly as comfortable designing with composites. So to address that barrier, IACMI put together a webinar for ASCE that really involved an all-star cast. You had Professor Diacar Penumato from the University of Tennessee, Francisco de Caso from the University of Miami, and the third all-star was Bill Davids from the University of Maine. because he talked about design of the FRP girders, the technology that has been developed at the University of Maine and commercialized by AIT as the G-beam girders. Bill talked about designing for moment, designing for shear, designing for deflection, and importantly, about validating that design. He did an excellent job. And this type of education of structural engineers is very important. And I'm going to talk more about education of structural engineers in just a few minutes. The third project I want to talk about has to do with fire resistance testing, which is a very important consideration for all kinds of infrastructure and construction applications. The project team for this project consisted of Trimer Technologies and Orenco. Trimer Technologies is a resin company with a novel resin system that they refer to as HARP. And Orenco is a fabricator in Oregon that produces composites that are used for wastewater treatment at ports and all kinds of applications where corrosion resistant is important. Orenco fabricated samples using the HARP resin, and FR testing, fire resistance testing, that was specific to infrastructure and construction was conducted at the University of Dayton Research Institute and Southwest Research Institute, and that testing was funded by IACMI. And the results were very good. They achieved a Class A E84 rating and a 60-minute E119 rating. So in terms of fire resistance, they checked both of those boxes. This project was highlighted in this banner at the 2024 SAMPI show, and you can access the entire report at IACMI's website. The final report is available with that link there. All right, let's talk a little bit about FRP rebar. I'm sure that many of you are familiar with FRP rebar. It can replace steel rebar as a reinforcement for concrete. It is 72% lighter than steel rebar, and it is much more corrosion resistant. And this is actually a slide that I obtained from John Bucell. It's called the I&C slide. It's a display at an international bridge conference, and it's a little bit hard to see, but you've got a jar here with a piece of composite rebar in salt water and a jar here with steel rebar in seawater. And after 52 hours, the steel has taken on the appearance of iced tea because of the corrosion. So FRP reinforced concrete is ideal for use in chloride-containing environments where there's seawater or de-icing chlorides around. So how have people taken advantage of the corrosion resistance of FRP? Well, the Florida DOT has really been a leader in the use of all kinds of FRP composites and FRP reinforced concrete. They've used it in all kinds of applications. This is kind of the poster child. It's the Halls River Bridge, which used a lot of GFR rebar. So you've got a state in the south that is surrounded by seawater, but FRP rebar is also used up north. It's used in my state because the Ohio DOT has used more than 1.5 million linear feet of GFRP rebar in their bridges. And their motivation is corrosion resistance in the winter months. So you've got interest in FRP in the south and in the north. So FRP rebar has been used to help produce corrosion-resistant bridges. Let's talk a little bit about the use of FRP rebar for offshore wind. I'm sure that many of you know that Maine has done a lot of work on wind energy and particularly on offshore wind. This is the Voltorn US prototype that has been deployed in the Bay of Maine. This was actually a design project at the University of Maine led by Anthony Vaselli. And I think most of you know that the blades are typically made with epoxy and glass. Maine has shown that the towers can also be made with vinyl ester composites. The purpose of this design project was to see if FRP could also be used to reinforce the concrete in the floating foundations. Again, this was a design project and the final report has just been completed. So, and here are the results. Can FRP be used in these floating foundations? And the answer is yes, it can. What the design work showed was that GFRP rebar could not be used below the surface of the water due to water tightness requirements, but they did find that FRP rebar could be used in the sections above the surface, and that is about 1/3 of the foundation. These foundations at full scale are enormous. A foundation can weigh 20,000 tons. So you're talking about 6,000 tons of concrete up here in the yellow section. The design work showed that the use of GFRP rebar could lead to a 10% reduction in the weight of the foundation. That's 600 tons. And the reason is because you needed a lower amount of concrete cover to protect the rebar from corrosion. 600 tons of concrete means that you're going to have much lower cost. You're going to have a lighter weight foundation. And remember, these things need to float. And you're going to have lower CO2 emissions because you're lowering the amount of concrete, which means you need less cement, which means you generate less CO2. So a very successful design project, and Anthony and his team are planning to continue to use this work as they move forward with scale up. Let's move from the past to the present, because now I want to talk a little bit about the decarbonization message for FRP. And this is an ongoing project. Because over the last several years, the Infrastructure and Construction Working Group has developed a very strong decarbonization message for FRP. It's very simple, that the use of composites can significantly lower emissions of CO2 and other greenhouse gases in infrastructure and construction applications. It's really a two-part message. That's true when they are used in place of steel and when they are used in conjunction with concrete. Not in place of concrete, but with concrete. So if you've attended the last two TIDC meetings, you've heard me talk about this decarbonization message, because in 2023, I gave you part one, where I showed you the reduction in greenhouse gas emissions when composites are used in a variety of applications, including the FRP girders that Bill Davids has been talking about. And I showed you double-digit reductions in greenhouse gas emissions when FRP is used. And then last year, I gave this presentation and I talked about part two, because I showed you that you could achieve double-digit reductions when FRP was used in conjunction with concrete. And the reason is that because FRP enables you to reduce the amount of concrete, which reduces the need for cement, which reduces the amount of CO2, just like in the floating foundations I just talked about. And I told you to remember this very simple equation. Concrete plus FRP equals lower CO2. So what do we plan to do? Well, what we plan to do is continue to spread this decarbonization message. The working group is continually strengthening the message and finding other examples where FRP can help decarbonize. Let me take a minute and talk about the decarbonization landscape, because it has changed in the last year. It's fair to say that the Biden administration had greenhouse gas reduction as a priority. That was reflected in programs at the Department of Energy, the Department of Transportation, and the EPA. The Trump administration has put a much lower priority on greenhouse gas emission, and they have eliminated or rescinded many programs along that line. That said, there still remains very significant interest in the private sector in decarbonization. Nearly every major construction company has published a commitment to lowering their carbon footprint. Here are examples from Bechtel and Kiewitz websites. Building owners and architects are interested in decarbonization. They want to get LEED credits for using building materials that lower emissions. And more than 100 structural engineering firms have committed to an initiative within ASCE known as SE2050. Say a little bit more about that. Here is the makeup of SE2050. Again, more than 100 structural engineering firms. I only recognize two in this list, Martin & Martin and WSP. So I consider this to be a very good target audience for our message. Here is the mission statement of SE2050, and I've highlighted some key words. They are interested in the reduction of embodied carbon by using less and less impactful structural materials. And when you read that, there is a very good fit between the mission of SE2025 and the decarbonization message for FRP that IACMI has developed. So what do we plan to do? Well, we're continuing to strengthen the message, but we've submitted an abstract to present at next year's 2025 Structures Congress in Boston, connecting fiber reinforced polymer composites to ASCE's SE2050 initiative. And this is the message that we're going to deliver to structural engineers. if they're interested in decarbonizing, if they want to lower greenhouse gas emissions, if they want to lower their carbon footprint, if they want to lower embodied carbon, if they want to achieve net zero, then they need to be considering FRP. This kind of education of structural engineers, this technical advocacy is very, very important. Another project that's in the definition stage has to do with updating the NCHRP report on FRP for bridges. This was a report entitled Advances in Fiber Reinforced Composites in Transportation Infrastructure. It was commissioned in 2013, completed in 2015, covered both new construction and refurbishment with composites. It's a very comprehensive report. It's more than 160 pages long, but it's a decade old. It's actually outdated. And in the recent I&C Working Group meeting, both the Florida DOT, Steve Nolan, and Maine DOT, Joe Stillwell, have encouraged an update. At the bridge conference that I was just at in North Carolina, the representatives from North Carolina, Virginia also endorsed this effort. So I would agree, because a lot has happened with bridges since 2015. We've already talked about the Halls River Bridge and the Grist Mill Bridge. Here you've got the Michigan DOT putting these CFRP wraps on bridge columns on the largest bridge in Michigan over I-75. You've got the Harkers Island Bridge in North Carolina, the longest bridge to use FRP rebar, 3,200 feet long. So you've got a long span bridge, and we've talked about the short span bridge when I talked about the Morgan County Bridge. And it's not just highway bridges. You've got pedestrian bridges, like this protruded one in Bermuda. And you've got cantilever walkways for multimodal transportation, like the one shown here. And this is a very important benefit of composites because it enables lightweight addition to existing structures. We believe that updating this report will increase awareness and drive further adoption of FRP in all kinds of bridges all across our nation. And if you're interested in getting involved in this, please see John Unser after this session. The last project I want to talk about is working with the Army Corps of Engineers. The Army Corps describes themselves as our nation's engineers, and they're involved with infrastructure like for inland waterways, like the locks and dams and levees shown here. However, when you look at the infrastructure report card, the grades for those categories are very low. So there's lots of room for improvement in categories relevant to the Army Corps. They are a user of FRP, but they're very interested in expanding their use of composites. And so we've been working to develop a strategic partnership with the Corps that is based on this roadmap from the Corps, which was published in June of 2024. It gives this prioritized list of FRP needs, or a prioritized list of needs, which is exactly what IACMI is looking for. And what we found in our initial discussions is that techno-economic analysis may be a good fit because it's a high priority for the Corps and it's a core competency for IACMI. In our initial discussions, the Corps has said they're interested in techno-economic analysis of pilings, so stay tuned. So, gets me to my summary slide. I hope I've shown you that there is an extremely good fit between FRP composites and our nation's infrastructure needs. This is a very good place to be right here. And I've also told you about the mission of IACMI's working group to increase the adoption of composites in infrastructure and construction through research projects, demonstration projects, and technical advocacy. It's been a very good first 10 years. Here's to the next 10 years. That concludes my presentation. I'd like to thank you for attention, and I'll be happy to answer any questions during the panel. And I believe that John Unser is actually also going to join the panel, so I have my wingman. Thank you, everyone.